Hello everyone. This is the second part of this discussion. Here we are going to discuss the chronology of the universe. Chronology, this word you become very popular few months ago. Chronology sounds lazy. So here we are going to discuss the chronology of the universe. Here, from the Big Bang to today's date, this picture presents the chronological development. This red arrow gives represents the time of this universe, different stages of this universe. So, the first um, beginning point was the Planck epoch, just after the Big Bang at around till around 10 to the minus 43 second. This is called Planck epoch. The Planck scale is the physical scale beyond which current physical theories may not be applied and cannot be used to calculate what had happened. Okay, so during the Planck epoch, cosmology and physics are assumed to have been dominated by quantum effect of gravity. So during the Planck epoch, this is just an imagination. What was happened there? What was the physical condition of the universe? Those informations we cannot extract because uh, those informations cannot reach to us because informations are carried by light, and light was not evolved at that time. Okay, though light was later on evolved, then also because of the density of the universe, those light get absorbed. Okay, but light was not evolved at the time. Only at the point of nucleosynthesis light was evolved. Okay, so we don't have any information about the Planck epoch. Then next phase is grand unification epoch. So here the three forces of this standard model, which are strong, electromagnetic, and weak, are unified, assuming that nature is described by the grand unified theory. Uh, this is a very um, interesting topic, grand unified theory. Whole year Einstein, after his five commendable work, five uh, best work published, he later on he was searching for this theory, grand unified theory, where uh, you and where he can find an equation that can describe the whole universe in a single nut. So but he failed to do that. Later on this Hawking also did something that cannot achieve the whole theory. So still it is going on. The search for a grand unified theory is going on. So next epoch is cosmic inflation and electroweak epoch. It is happened in around 10 to the power up to 10 to the power minus 32 seconds. This cosmic inflation expands space by a factor of order 10 to the 26, and the strong interaction interaction becomes distinct from the electroweak interaction. The universe starts expanding due to this inflation of this universe cosmic inflation that expands this space at a very high rate, and the electroweak interaction and the strong interaction become distinct. Next era is particle era, and the forces of the standard model have been separated, forming a quark-gluon plasma. So, to form this plasma, you will be this quark and gluon. Those are very tiny, but means building blocks of these elementary particles. So we can say that the particle have been just evolved. Okay, because this plasma has been generated at that time. So this Large Hadron Collider is trying to create this high energetic situation to study the early universe. Okay, LHC is very popular nowadays. The Planck Big Bang nucleosynthesis that occur at around 10 to the power minus 3 second to 200 seconds. So just after the Big Bang, the nucleosynthesis have been started at around 10 to the power minus 3 second to 200 seconds, where protons and neutrons are bound into primor primordial atomic nuclei, very tough word by hydrogen and helium-4. Small amounts of deuterium, helium-3 and lithium are also synthesized. So in this Big Bang nucleosynthesis, this hydrogen, helium-4, helium-3, lithium-3 have been synthesized from this elementary particle. So next era is the era of nuclei, and that the duration of this is 200 second to 500,000 years. The universe consists of plasma of nuclei, the electrons and protons, and temperature remain to uh, too high for binding the electrons to nuclei. Next era is the era of atoms, which starts from 500,000 years to 1 billion years, where electrons and atomic nuclei first become bound to form neutral atoms. Then the photons of this cosmic microwave background radiation originate. So from the era of atoms only we can have okay, we can have the information of this the universe, because now the photons photons have been created, and we are collecting those photons in the microwave region, and which we call as microwave background radiation. This microwave background radiation contains the information of the early universe. Next era is the era of galaxies, which started from 1 billion years to the present day, and all the stars, galaxies, clusters have been formed in this era, and also keep on forming. So we are getting uh, we are seeing the present scenario, which is at the era of galaxy. So from the very beginning, from the Planck epoch to the era of galaxy, this is the chronology of the universe that we have. Okay, so here in this picture, you can have a more detailed idea of this chronology. Here we are presenting here in the left side, we are presenting the time since the Big Bang, from very beginning, from the Planck era to the present date, and these are the eras, different eras of this the universe, and this is the animation of the different eras. What are the constituent elements present at that time, and this is the constituent elements. This gives the constituent elements of the universe at different era, and this gives the what we can observe. The last line in the left right hand side, most the part gives the uh, different observations, the different events what we can observe from the very beginning of this universe. Now here we see that this is the Big Bang, and just after Big Bang it is Planck era, and what was the event there, it is still a question mark, actually large question mark, several question marks. So we don't know what was there in the Planck era. The next it is GUT, Grand Unification Theory era, where elementary particles may have evolved. Okay, and what was there? Nothing was there. No information was there. Then after 10 to, up to 10 to the minus 15 second electroweak era, and these elementary particles are evolved, and the strong force become distinct, perhaps causing inflation of the universe. Universe has suddenly expanded, and in this electroweak era. Then come to the particle era, where elementary particles, antimatter common, elementary particles have evolved, and what we can see, electromagnetic and weak forces become distinct. Then era of nucleosynthesis. In this era, protons, neutrons, electrons, neutrinos, antimatters have been seen, and matter annihilate to antimatter. This event has been started, and also fusion have been started here. A normal fusion of normal matter is in fusion cases, normal matter is 75% of hydrogen and 25% of helium by mass, because 4 hydrogen is required to produce the helium. So hydrogen number should be bigger to produce helium, and 25% helium was there at the time in the era of nucleosynthesis. Then in the era of nuclei, plasma of hydrogen and helium nuclei plus electrons have been evolved. The atoms form photons, fly free and become microwave background. Yes, at this moment, era of nuclei, the the density of the universe become reduced, and the photons that have been evolved in these reactions, they are able to cross the periphery, able to cross the whole universe and come to the periphery of this universe. So but still maximum photons were uh, absorbed by different elements. Then the era of atom starts, where the atoms and plasma starts being to form, and this happened. This microwave background is still going on. Then the era of and also the first galaxy have been formed because of this era of because atoms have been formed. Then from 1 billion years to the present date, era of galaxy. This is the era of galaxy, where stars, galaxies and clusters made of atoms and plasmas, they are now seeing. The human observed this in the cosmos. So we are seeing the present day scenario, which is the era of galaxy. We see different galaxies, different large objects, different clusters, etc., etc. So this is what we see today, and it's evolved from a singularity and a big bang, which uh, which, which was occurred in around 10 to the 13.8 billion years ago. Okay, this is the big bang. There's what is called uh, chronology of this universe that we have discussed. In the next topic, we'll be discussing the cosmological models. So here already 13 minutes is done. So let's finish this session. We'll be coming again with this cosmological model in a with a separate video. Thank you so much till here.